Let's just jump right into this explainer, shall we? Today, we are building an AI agent, completely from the ground up. We're going on a pretty wild journey, starting from a basic language model that's really just guessing the next word, all the way up to a fully autonomous, multi-agent system that can practically run a business. We are taking a highly structural approach today. First up, language models and their limits. Then the rise of AI agents, how they actually reason and act, enhancing them with memory, scaling up with tools and MCP, and finally, the future of AI teams. The goal here is for you to clearly see the real engineering behind the magic. Section 1. Language models and their limits. Think of this as the brain of the operation. To really get started, we have to understand this core brain, the large language model, or LLM. At its most basic level, an LLM is simply a mathematical representation of language. It's a statistical tool designed to do one main thing: predict the next word or character based on absolutely massive data sets of human writing. It's not inherently intelligent. It's just unbelievably good at identifying statistical patterns. Now, what's absolutely mind-blowing here is that despite being built literally just to predict text, these models developed this unexpected emergent ability to mimic human reasoning. Because they were trained on our thought processes, our motivations, and our problem-solving steps, they somehow learned to break complex problems down into smaller, manageable pieces, chaining their thoughts together. But there's a catch, right? This reasoning is really just an imitation. They don't possess true understanding or real-time factual accuracy. Because they operate probabilistically, they act a bit more like high-tech slot machines of probability. They don't actually know what an apple is. They just know the statistical likelihood of words associated with it. And that, unfortunately, makes them pretty prone to logical errors and inconsistencies. And this brings us to a hard limit. Your brain in a box might draft a completely brilliant piece of code or write a perfect email, but it's trapped. It can't execute the code, it can't click send, and it definitely can't buy stocks. Enter the AI agent. Suddenly, that brain has a robotic arm to actually do things in the real world. It completely bridges the gap between simply thinking about a task and actually executing it. Section 2, the rise of AI agents, which is all about giving that brain some hands. Let's see exactly how we transform that static LLM into an active, capable agent. To turn an LLM into an agent, the very first thing we have to do is give it an identity and set its boundaries. We do this using what's called a system prompt. This gives the overarching directions that tell the agent its role. Maybe it's a formal legal assistant, or perhaps a friendly but legally compliant travel guide. We also combine this with safety guardrails to ensure the agent only operates securely within acceptable, predefined parameters. So once the agent knows who it is, we hand it tools. These tools are software capabilities, things like functions, APIs, or communication interfaces, that the agent's LLM brain can call upon. If it needs to know the weather, it uses web search. Need to do math? It grabs the calculator. Looking for a file? It queries the database. The LLM does the reasoning, but the tools are what actually execute the action. Section 3. How agents reason and act. The methodology. Now that our agent has a brain to think and hands to act, we really need to understand the methodology it uses to systematically solve problems. This sequence is the absolute magic of the REACT framework, which stands for reason, act, and observe. When given a task, the agent first uses its LLM to reason and decide on a course of action. Second, it acts by triggering a specific tool. Third, and honestly most importantly, it observes the outcome of that action to see if the objective was fulfilled. If it wasn't, it loops right back to step 1. Because LLMs are probabilistic, this looping mechanism is absolutely vital. An agent might use the wrong tool or search for the wrong keyword, but instead of just crashing, it observes the failure, acknowledges the logical error, and tries a totally different approach on the fly. It loops, it iterates, and it self-corrects until it finds the correct solution. But here's the kicker. While looping solves immediate task-based errors, a static agent suffers from severe amnesia. It resets completely after a task is done. It cannot build a relationship with a user or remember what you asked it yesterday. And that brings us to our next major architectural leap. Section 4, enhancing agents with memory, giving the agent a past. This is where we transition the agent from being a disposable utility into a personalized, highly efficient assistant. We achieve this transformation by integrating 2 specific types of memory. Short-term memory retains context during a single session, so you don't have to constantly repeat yourself in a back-and-forth chat. Long-term memory, on the other hand, stores vital information in sophisticated embeddings databases. So, if you tell an agent you prefer Japanese restaurants and like to dine at 7:15 p.m., long-term memory allows the agent to draw on that context weeks later. It behaves much like a real human assistant who actually knows your habits. But how does the engineering actually work behind the scenes? How does the agent know exactly which memories to recall? Well, it uses thread IDs. These are configurable parameters that group specific conversations into coherent threads. It ensures your agent knows exactly which past conversation to draw its context from, completely preventing it from confusing your dinner preferences with your work calendar. But as we start relying on these agents more and more, a totally new problem emerges. Building custom tools for every single agent inside a company is incredibly inefficient. Think about it. If I want my agent to query a credit card database, and you want your agent to do the exact same thing, how do developers scale this without reinventing the wheel every single time? Section 5. Scaling with Tools and MCP. The ecosystem. This introduces us to the digital environment where modern agents live. It's a framework that allows them to discover and borrow capabilities seamlessly, right on the fly. Enter the Model Context Protocol, or MCP servers. You can think of an MCP server as a giant resource hub, or maybe like a digital hardware store. Instead of hard-coding a tool directly into an agent, developers set up an MCP client. The agent can dynamically query the server, ask what tools are available, and instantly plug them in via asynchronous calls. It's literally like realizing you need a power drill and instantly downloading one from a friend exactly when you need it. Let's look at why this is just so powerful in practice. Imagine you ask your agent a highly complex query, something like calculating future investment values based on fluctuating interest rates. A basic calculator tool is going to fail there. But via the MCP server, the agent can discover and borrow an experimental tool called the Python RAPL tool. This empowers the agent to actually write and execute real Python code to solve the complex math perfectly, expanding its capabilities immensely. Section 6. The Future of AI Teams. Multi-agent systems. Okay, let's dive into this final piece and see exactly how reasoning, memory, and tools combine to form advanced collaborative AI teams. Depending on your workflow, you have a few architectural choices here. A single agent system handles everything independently, kind of like a standalone customer support bot. Tool-augmented agents, as we've discussed, reach out to external APIs. But the true frontier we are entering is the multi-agent system. We're talking about an entire virtual workforce where multiple specialized agents, each with distinct roles, like a sales agent, an inventory agent, and a logistics agent, all collaborate to complete massive, complex tasks. In a multi-agent setup, compartmentalization is your absolute best friend. Take healthcare, for example. You might have one agent specifically for web searching and a totally separate agent for advising patients. By strictly separating their tools, you ensure that Web Search Agent can never accidentally leak a patient's private health records onto the public internet. Compartmentalization guarantees security. But how do these highly specialized agents actually talk to one another? Well, under the hood, they use established tech protocols like JSON to structure data and HTTP to communicate across servers. But quite remarkably, because their core brains are large language models, these agents can also communicate with each other and with us using natural, plain English language. This makes managing a complex team of AI agents incredibly intuitive. As we wrap up this explainer, I really want you to step back and look at the anatomy we just built. We took a basic statistical text predictor, we gave it tools, we taught it to reason through errors, we handed it long-term memory, and we connected it to an ecosystem of limitless capabilities. As this massive leap from text generation to true multi-agent automation reshapes the workplace, ask yourself, what complex daily workflow are you going to delegate to your AI team first?